All right, so today we're going to do Pythagorean theorem. This is the Pythagorean theorem folder, foldable, and it looks like this. Turn it on this side, so the side that should be facing up is the side that just says solve to see if. All right, we're going to make a trifold out of this. So first we're going to fold the right side over where it says vocabulary. We want kind of 3 equal parts. So vocabulary is the first thing that we kind of fold over. Not 4, just 3. Fold. Okay, yes, no. It's 3 sections. Just fold this section over. Yes, sir. Slide it over some more. That's not you cutting off words.
Just slide it over halfway.
A third of the way. Yes, good.
I just did it right.
Hush, you did it right. You just said the wrong fraction. It's all good. And now we're just gonna fold this over. And I probably folded over a little bit too far. Shh, guys, when you leave out, please make sure the door stays open until you get back, okay? All right, and then fold this over so that Pythagorean theorem is on the top. Okay, so it looks exactly like this. And I'll pause for the color. Okay, so Pythagorean theorem. This is how this started. Real quick, there was a little guy back in the day, long time ago. His last name was Pythagoras, and he had a theory. Okay, and his theory was that he would be able to take 2 squares and have, well, 2 sides and form them into squares, and that these 2 sides, if you add them together, if you add the 2 squares together, it's going to give you the answer to the 3rd square. So he actually created, just listen, he actually created a theorem that allowed you to find the missing sides of a right triangle. Okay, so the theorem is called Pythagorean theorem. Now, when a theory is proven to be true, that's when it becomes a theorem. So he started off with a theory, but then he did thousands of tests. I'm exaggerating, but he did tests, and every time he did those tests, it came out to be true. So then the theory becomes a theorem. Now it's proven to be true. All right, so we got Pythagorean theorem. Pythagorean theorem, super important, is a formula that's used to find the missing length or one of the missing lengths of a right triangle. So Pythagorean theorem's formula used to find the missing length of a right triangle. And it can only be used with right triangles, okay? That's it. That's it. That's all. How do I know by looking at this triangle that it is a right triangle? Yes. It has a right angle. Where is the right angle? In the corner. And how do I know that it's in this corner? Because of the little box. This box is an indicator that this angle is exactly 90 degrees. Okay? So this is the theorem. We're going to write the formula for the theorem right here. It's a squared plus b squared equals c squared. It is where a, b, and c are actually numbers. A, B, and C are numbers. They are side lengths, 3 of them. So they are side lengths of the triangle, of a right triangle. Your A and your B are the 2 sides that form that form the right angle. Your A and your B are called legs. Very simple. Okay? The two sides that form the right angle of a triangle are called legs. So it doesn't matter if you label this A or B or this A or B. This could be B and this could be A, this could be A and this could be B because they're both legs. Okay, so your A and your B are your legs. Those are the two sides that form the right triangle or the right angle. Sorry. Your C is called the hypotenuse. Okay, it's the hypotenuse. Hypotenuse. This is just the name. Your hypotenuse or C is the slanted side. It's the longest side out of the three. It's the longest side out of the three. And it's the side that's opposite of the right angle. Because sometimes when you look at it, if you see the triangle and it's flat just like this, you can't really tell that it's the slanted side, but it really is. So a good way to identify it is it's always the side that's opposite of the right angle. No matter how it's turned or tilt, it's always going to be the side that's opposite of the right angle. These two sides are always going to be A or B, A or B. You can label this A and this B or this A and this B. Doesn't matter. Okay? Any questions about that? So this is how he proved his theorem to be true. What he found out that is if it's a right triangle, if it's a true right triangle, and you take this length right here and make it into a square, and this length right here and make it into a square, and then this length right here and make it into a square, that when you add these two squares together, it's going to equal this square right here. Okay? And so that's how he's able to substitute values into the formula to figure out the side that's actually missing, whether it's A, B, or C, because he's proven that this formula actually works, but only for right triangles. Okay? So let's look and see if this is true. How many squares is this? This is 9. Okay. So this would be A squared here would be 9 because this length is 3. 3 times 3 is 9. So this is 9. Not a A, but a 9. I need to make it look like a 9. Okay. Because this length is 3 and this length is 3. 3 squared is 9. Do you see that? How this is 3 and then this is 3 and then 3 squared is equal to 9. Okay, that's the A squared. All right, so let's look at this one. How many squares or how many units is this?
16.
This is 16. This length right here is how much? 1, 2, 3, 4. Okay, and this is what? 4 also, right? Because you make it a square. So B squared, that's 4. 4 squared is equal to what number? 16, right? Okay. All right, so let's look at this length right here. What's this length? 1, 2, 3, 4. How many? 5. So how many units is this all together? Don't do that, honey. Don't be slow. This is 25. Okay. So that's 25. So this would be 5 squared. What's 5 squared? 25. Okay. See how that's C squared? So is this true? 9 plus 16 is equal to 25. Yes. So he proved that this is always going to be true, but that it only works for right triangles. It doesn't work for any other kind of triangle. Okay, let's open. Let's, right angle. What's a right angle? An angle that's what? It's
90 degrees.
okay, an angle that's exactly 90 degrees. Okay. What are the legs? Your legs are it's A and B, but it's the sides that form. Very good. It's the sides that form the right angle. The sides of a right triangle, because that's important, right? That form the right angle, right? And what letters are those? A and B. Sides A and B. A and B. All right. What's the hypotenuse? It's the side opposite of the right angle. Okay. And what else did we say about it? It is the letter is C. And what else did we say about it? The longest side out of the three. It's the longest side. And it's also the slanted side. Okay. Okay. Don't forget to put that this is side C. This is your C. Square root symbol looks like a little check and then a long line on the top. That's your square root or radical symbol. Okay. To find the square root of a number means that you're going to find one number that can be multiplied times itself to give you the number that's under this radical. Okay. When you're finding the square root, to find one number that can be multiplied times itself to give you the number under the radical. Under the radical. Or under that square root sign. Okay? Okay. Any questions about that? Are you okay? Now we're gonna do some examples, okay? Let's look at example number 1 right here. We're gonna examine to see if this is a right triangle. Okay, if it were a right triangle, this is the only side that could be the right angle. I'm put a little question mark because we're not sure it's a right triangle yet, but we're gonna examine to see if it is. So if it was, this would be your A or B, and this would be your side C. So we're going to use Pythagorean theorem to see if it is a right triangle. Okay. All right. So our A is 5. So this is 5 squared. That's the length. We're going to make a square out of it. We're going to make a square out of this side plus 12 squared. And we're going to make a square out of the third side to see if these two squares, when you add them together, will equal to the third square. Okay? So we got 5 squared. How many units is that going to be? So this square over here will be 25 units. Okay? How many units would this square down here be? 144. 12 times 12 is 144. And then how many units would this square be? What's 13 times 13? What? 169. Okay. All right. So let's add these two together. Let's add these two together to see if it's equal to that. So 144 to the side plus the 25. So we got 5 and 4 is what? 9. 4 and 2. And this is 1. Is that right? So this is 169. It's equal to 169. So yes, this is a right triangle. So this is a yes. This is a right triangle. Any questions? If both sides are not equal, then you would say, no, this is not a right triangle. So if this side was 160 and this side was 169, you would say, no, it's not a right triangle. So now let's look at example number 2 and see if it's a right triangle. If it were a right triangle, then no question, this is the only angle that could possibly be a right angle, right? If. That's why I got a big old question mark. This could be my side A, this could be my side B, and this could be my side C, okay? So now we're going to substitute these values into the formula to see if it is a right triangle. So we got A squared plus B squared equals C squared, all right? Your A is 6, so we're making a square over here. Yes, baby?
It don't matter which side is B or not.
Which A and B, as long as it forms the right angle. But it does matter that C has to be the side opposite of right angle. You have a question, baby? Okay. B is 9, so this is 9 squared is equal to 10 squared. Good job. Okay. So now, what's 6 squared? So this rectangle, this square over here will be 36 units. Plus, what would this square down here be? 81. Plus, what would this square up here be? Huh? 100. So let's add these two together. We got 36 and 81. Is that 100? No, this is not 100. This is 6 here. And what's 8 plus 3?
117.
Oh, 7. I put 7. Sorry, y'all. 6. All right, so this is 117 on this side. And what on this side? Is that equal? It's not equal. This symbol represents not equal, okay? So that means this is not a right triangle. This is not a right angle. Okay? It's just a triangle. This is not a right triangle. Any questions about that? Guys, any questions about that before y'all start moving? Okay.
This one. You gonna do this one later on?
Yes. All right, we'll finish the others tomorrow.